going on, guys? In this video we are going to see how to find out the Laplace transform of 1 over square root of t. To find this one, first let's look at the general formula. General formula is we will have a integration that goes from 0 to infinity. Here t is equal to 0 and go to infinity, and we will have e power negative st, and the function here, our function is 1 over square root of t, so I put that one right here, and then we integrate the whole thing with respect to t. This is the general formula. Now let's see how we can do this integration. To do this integration, we can do the U substitution. So to do the U substitution, we are going to completely eliminate the t terms. So to eliminate t terms, first I can take this st as u. If I take st is equal to u, then I have to replace this t with this s and u terms. So if we rearrange this t is equal to u over s. So instead of square root of t, if it's square root of t, then this is going to become square root of u over square root of s. Okay, that's how we are going to replace this one. And also we have to replace this dt in terms of u and s. So if t is u over s, then dt is going to be derivative of t. Okay, dt is, if t is u over s, and then dt is going to be 1 over s du. Okay, we are going to do the integration with respect to u, so we just have to do the derivation for u. So instead of u, we will have du. So we can replace the dt like this, and if we rewrite this one, this is going to become t is equal to 0 to t is equal to infinity, and then e power negative st. Instead of st, I put u right here, and 1 over square root of t. 1 over square root of t, and we know that square root of t is square root of u over square root of s. So 1 over square root of t means it's going to flip around, like this is going to become square root of s over square root of u. Instead of d, we will have 1 over s du. I put the 1 over s in front, and we will have du right here. And here we are doing the integration with respect to u, so we can take this s to the front because s is going to be just a constant. So this is going to be square root of s over s, integration 0 to infinity, e power negative u, and if t is 0, and if you substitute, like if I write this one in terms of u is also going to be 0, because if we rewrite this one in terms of u is equal to st, and if you plug 0 for t, the whole thing is 0, so we will get 0 in the denominator. I mean, no, the lower limit is going to be 0, and if you plug infinity for this t, you will get u also infinity. So for u also, u is equal to 0. The limits of integration is u is equal to 0, u is equal to infinity. And we will have 1 over square root of u right here, du. Here we are going to do one more thing. We are going to do another substitution. In the substitution, what we are going to do is, we are going to equate another terms, like instead of square root of u, we are going to replace that one with w. So w is equal to square root of u, then u is going to be equal to w square. Okay, here we have to replace this square root of u and also this negative u. So in the negative u, I can replace it with negative w square, because instead of u, I plug w square, and instead of this square root of u, I replace that one with w. We have to also replace this du, get rid of this du. To get rid of this du, we can just take the derivation of this one, dw. That's going to be 1 over 2 square root of u du. And since we are trying to replace du with w terms, so we have to rearrange this one. If we rearrange this one, this is going to be, actually I can get rid of this 1 over square root of u du all together with this one, like 2 dw is equal to 1 over square root of u du. So all together I can get rid of this one, so we don't have to worry about plugging square root of u alone and stuff. So we can all together get rid of that one, and this s over square root of s over s is going to be just square root of s, because s we can, like 1 over square root of s, because s you can expand it as square root of s times square root of s. So this is going to be just 1 over square root of s, and this is going from 0 to infinity, and e power negative u, instead of u I put the w square right here, and 1 over square root of u du is equal to 2 dw. So I put the 2 in front because that's just a constant, and dw right here. And here from this one we can we know like there's a famous integration that's called Gaussian integration. That says when you have 0 to infinity e power negative w squares dw, something like this, you can integrate this one as half negative infinity to infinity e power negative w square dw. This is called Gaussian integral. So finally this is all equal to half square root of phi. That's what we are going to do right here. So if you look at this one, here we have the same thing, right? The only thing that's missing is, if you like, this is 0 to infinity e power negative w square dw. So all together we can replace it with half square root of phi, because that's how the integration will end up. And then if we do that, this is going to be 2 over square root of s in the we have previously, and instead of this whole thing we are going to replace it with half square root of phi. And if you simplify, this is going to be this 2 cancels, and finally we will end up with square root of phi over square root of s, and that's going to be the Laplace transform of 1 over square root of t. And that's how we do that. I hope you guys find this video helpful. Thanks for watching. And if you are trying to learn differential equation, there are a bunch of videos in my playlist. I hope you guys watch that too, and don't forget to subscribe. See you next time.